In this tutorial, we are going to solve this question, that is section B, question 1, that is B1 from 2024 science paper 1. So we can say physics. So the question is saying figure B1.1 is showing the time recorded on a stopwatch for 40 complete oscillation by Elena during an experiment on a simple pendulum. So from the diagram that we have here, guys, we can clearly see that we have a stop, then we have got a mode and start. So what I want you to understand is that this stopwatch will always be in these are minutes, then these are seconds. Okay, so like in this case we have got 0.1 minute and 40 seconds. Okay, now I want you to understand that in 1 minute we have got 60 seconds. These are the things that you guys should know. Okay, then again in 1 second we have got 60 milliseconds. Another thing that I want you to understand, although most of the time they'll never use this one, but they'll just use minutes and seconds, but I want you to understand that in 1 hour there is also 60 minutes. Then in 1 minute there is again 60 seconds. These are the conversions that you need to be familiar with. So the first question here is telling us to say, state the time taken in seconds for the 40 oscillations. So the time that we have here is just basically for us to convert the minute, the 1 minute to second, then we add the 40 seconds. That will be our time in this case, because it took 1 minute 40 seconds to complete 40 oscillations. Okay, now to do that I need to understand that in 1 minute there is 60 seconds. So what I have is 60 seconds plus 40 seconds, which is going to give me 100 seconds, because 60 plus 40 is 100. So 100 seconds, that's the time that I'm going to have here. So now in the next page the question continues to say we need to calculate the period, the period of the pendulum. So what I want you to understand is that period is basically, in the SI unit for period is in seconds. So period is given by the total time in seconds. So in that case we're going to say in seconds, divided by the number of oscillations. So this hash means the number of oscillation. Okay, so now we can clearly see that period, now in simple terms, this period is represented by T, capital T. We call that as period. So period will be equal to the total time. We have been told that, not we have been told, we have found that the total time is 100 seconds. So I'll go there and write 100 seconds. I divide it by the number of oscillations. The number of oscillations is 40 from the question. So I'll put 40. This one has got no units, it's just the number of oscillations. So now we have the period, which is 100 divided by 40. That gives me 2.5. So 2.5 seconds is my period. So then here 2.5 seconds is my period. Another question continues to say calculate the frequency of the pendulum. How do we find the frequency? So the frequency is given by 1 divided by the period. In other terms, we can say that the frequency is given by the number of oscillations, okay, divided by the time, the total time. So you can either use this formula or you can use this formula and you end up having the same answer. So I'm going to use both formulas in this case. I'll start with this one. Okay, so frequency is equal to 1 divided by the period is 2.5, which is seconds. So then the frequency will be equal to, So then the frequency will be equal to, so you do 1 divided by 1.25, I'll end up having 0. 0.8 hertz. Is this correct? So we are saying 1 point, oh, it's 25, not t. So 1 divided by 2.5, yeah, 0.4, sorry. So 0.4 hertz is my frequency. Now what if I use this formula? So if I use that formula, frequency will be equal to, the number of oscillation is 40, the total time is 100. So what we are actually doing is 0 and 0 can go. So what I'm actually doing now is 4 divided by 10, that is 0.4. So I'll end up having the same thing. So you choose which method to go with. Okay, so that is it for this question 1.